All right, folks, it's Bass Action back in action. Now that we've gotten some practice with our unit circle, you guys have been practicing with that on the practice quizzes and getting comfortable with the unit circle, we want to look at how we can use our trig ratios on circles that are not a one unit circle. So how can we apply our knowledge about the trig functions to understand other trig functions when it's not specifically the unit circle? So for example, we've got this first example here that says that we have an angle, and it specifically tells us that it's an acute positive angle. And what it's going to do is it's going to give us just a single trig ratio. And what we know is that that single trig ratio can actually be used to help us find all of our remaining trig ratios. So what we're going to do is we're going to think about triangles here. So if it's an acute positive angle, what I'm going to do is I'm going to just make a very quick sketch. These are not going to be to scale or anything like that. So I don't want these sketches to take more than about 10 seconds for you to quick put on there. So if it's an acute positive angle, it has to be in the first quadrant. So I know that I've got some angle in the first quadrant, and what I'm going to do is I'm going to drop a perpendicular. It always has to be on the x-axis, and I'm going to imagine that my angle theta is right there at origin. And then, understanding just basic SOHCAHTOA, our sine is going to be opposite over hypotenuse, which means I can use that to label this triangle. So the opposite from that theta is going to be 7, and the hypotenuse is 11, which means we can very quickly do a Pythagorean theorem. And if this is a triple, I want you to be able to do this in your head. A Pythagorean theorem question should not take any more than 10 seconds to do. These are supposed to be quick. So quick thinking Pythagorean theorem, I'm going to have 121 equals 49 plus an x squared. So I can quickly see that my x is going to be the square root of 72, which of course I can very easily rationalize that in my head and get the last side of my triangle is 6 radical 2. That should be very, very fast. From there, what I can do is I can come over here, and now that I have a complete triangle, I can answer any trig function that I want. Secant, of course, I understand, is the reciprocal of sine. So instead of opposite over hypotenuse, it's hypotenuse over opposite. I can either look to my triangle, or I can look to the original ratio I was given in this case, and I know that if I want to write this down, I can. I know that it's automatically going to then be 11 over 7. Now, cosine is going to be my adjacent over my hypotenuse. It's important to understand this is not a unit circle. In fact, our triangle shows us that it's 11 is the radius of our circle. So adjacent over my hypotenuse, just reading from my triangle, I have a 6 radical 2 over 11. And my tangent would be my opposite over my adjacent. So I'm going to have a 7 over 6 radical 2. And of course, I do want to rationalize that if I'm going to have that opposite over adjacent. So I'm going to multiply the top and bottom by a square root of 2. I'll write it here, but I want you to be able to do these in your head. So if I finish rationalizing this, I'll get a 7 radical 2 over 12. So that takes care of that one. So let's take a look at just one more example here so that we can look at another sample here. So this time it gives us cotangent. It's still an acute positive angle. So we can come over here and we're going to quick draw in our triangle. Since it's an acute positive angle, I know it's going to go right there. I can fill in my theta. Cotangent, of course, is the reciprocal of tangent. So it's going to be adjacent over the opposite. So the 8's going to go here and the 5's going to go here, which means I can quick do a Pythagorean theorem. And I'm going to have my 64 plus my 25. That's going to get me an 89. It's not going to simplify, so I'm going to have a square root of 89 on that hypotenuse for me. So now sine, opposite over hypotenuse. And I'm going to have 5 over square root of 89. Got to, of course, rationalize that. So this time I'm not going to write it down. I have 5 square root of 89 over 89. Secant is going to be the reciprocal of my cosine. So instead of adjacent over hypotenuse, I'm going to do a hypotenuse over my adjacent. So now I'll have a square root of 89 over an 8. And really, remember, I'm just reading these from the triangle. We're just thinking basic geometry, reading those ratios. Tangent, opposite over adjacent. I can read from my triangle, but I can also recognize that my original function was a cotangent. So I really just need to do the reciprocal of that. So I'm going to have a 5 over an 8. So those are some quick examples if they just give us just a simple ratio and no other information. Now, the next one is similar, but they really kind of back us up one more step. So instead of actually giving us the ratio, what they're going to do is they're going to actually just give us a point, and they're going to tell us that it's on the terminal side of some angle. So in this case, we're not guaranteed that it's going to be in the first quadrant. We have to imagine where is that point. So if I wanted to plot the point -2, 3, I would of course go -2 and up 3. So my angle needs to be in the second quadrant. Again, drop the perpendicular, so that means theta's right there. If this is my XY pair, then this is my -2 and this is my 3. So this one's going to be jumping out to us as a pretty easy one to do our Pythagorean theorem on. We can quick do this, so we'll have a 4 plus a 9 is going to equal our x squared. So we can just fill very quickly in that square root of 13. So now, moving from there, again, we're just going to start thinking about working with our triangle and filling in our ratios. Again, cosecant, it's the reciprocal of sine, so I'm going to do the hypotenuse over the opposite. So my hypotenuse is the square root of 13, and my opposite is 3. Cosine, my adjacent over my hypotenuse. So my adjacent is a -2. My hypotenuse is a radical 13. So I'm going to rationalize that. -2 square root of 13 over 13. Notice that my ratio turned out to be negative, and I was in the second quadrant. That makes sense. It totally connects back to our all students take calculus. And my last one here is my cotangent. That's going to be my adjacent over my opposite. So my adjacent is a -2 and my opposite is a 3. So those are our 2 new examples of working with our ratios that are not on the unit circle and how we can fill in the remaining parts.